In this section, we want to actually now solve a polynomial function. We looked at how we might describe it. We looked at how we might look at a graph and find some things out about it. We looked at how we might be able to, using some theorems, come up with some different ideas about how to solve it. But now we actually want to put that all together and actually solve the polynomial. So when we solve a polynomial, there's a few things that we need to look at or talk about first. One thing we want to talk about is the multiplicity. The idea of a multiplicity, which is also called a repeated root, means that the factor or the solution is counted more than one time. It can look like a couple of things. I can look at this multiplicity and look at it in a factored form and see that it's got an exponent of more than one, meaning that if I have the factor, let's say, x plus 7 squared, that means that there's actually two solutions at this spot, which means x equals -7 is a repeated root. Or we can also say that it has a multiplicity, so it's going to be multiplied by itself, meaning that if I were to really expand this out, we know that x plus 7 squared is really x plus 7 times x plus 7. That's where they get the idea of multiplicity or multiplied more than one time, right? So that 2, that exponent of a 2 for the factor means that it's going to be repeated, and this number, because it's a 2, tells me how many times. It would be multiplied on there twice. So the reason that this is important is because if I'm trying to look for a specific number of solutions, say that the highest exponent of my equation, which tells you the number of solutions, say that's a 6. That means I'm needing to find 6 solutions. Well, if I only find 4, the question is, well, where are those other 2? Well, it might be that there were only 4 because some of them are repeated and they are multiplying more than one time. So I might need to double count or triple count one of those solutions. So let's look at it from the beginning. When we have a polynomial function and we want to solve it, we want to find those solutions. The first thing that we're going to do is we're going to set that equation equal to 0. Now, whether we have an equation in standard form or factored form, that is still the first step. Set that equation equal to 0. Then when we go to find the solutions, I can do one of two things. I can either factor it, so if it's already in factored form, it's ready to go. Or I can use those theorems that we looked at, where I'm going to use my rational root theorem to make my list. I'm going to then either use synthetic division or my factor theorem to plug in or synthetic division with that value, and then I'll be able to see if the remainder is 0, meaning I have a solution. So we're going to give this a try, okay? So we're going to look at a couple examples here. We're going to start off with one that's in factored form because, of course, it's a little bit easier to do, and then we'll look at a few more where we're going through multiple steps, okay? So let's say that our first example here, we have the function f of x is equal to -2x times x minus 1 times x plus 3 squared times 2x minus 1 squared. All right, so when I look at this function, if I'm trying to solve this polynomial, the first thing I'm going to do is I'm going to set the equation equal to 0. Remember, the reason we want to do that is because to find a solution is the same thing as finding the x-intercept. And when we find the x-intercept, we set the y value, or, right, this f of x, we set that equal to 0. So that's the first thing that we want to do. Now what we want to do, since it's already in this factored form, the solving is going to be very simple. I don't need any of the rational root theorem or the remainder theorem. All I need to do is say, well, since I have them factored, I'm going to set each of these factors equal to 0, and I'm going to solve it. So I'm going to set each one equal to 0, and then we're going to go solve for each of our zeros. Okay, so if I look at the first equation, I would divide by -2, so x equals 0. I would add a 1 on this one, x equals 1. I would subtract my 3, so x equals -3. I would add a 1, divide by 2, so x equals 1/2. Anything, oh, okay, well, I must be finished, right? I solved everything. Well, let's go back to the very beginning when we were trying to determine how many possible rational solutions we had. Remember, we were using that leading coefficient test. And to do that, what we were going to do is we were going to add up the number of exponents since it's in factored form. So I have 1 there, 2 there, 3, 4, 5, 6. So I should have 6 possible solutions. So now the question is, well, I only have 1, 2, 3, 4. Uh-oh, I'm supposed to have 6. So what happened? Well, let's go back up to our equation, and I notice that I have right here this squared, which means that they are repeating. So this -3 is what we call a repeated root. It's going to count twice, right? It's got a multiplicity of 2. So really, when I start counting, I'm going to double count this -3. It's as if it's on there twice. And same thing with my 1/2. It's got a multiplicity of 2 also. It is on there twice as well. So what really happens is when I go counting, I have x equals 0. So that's 1, 2, 3, 4, counts twice, 5, 6. So there's all 6 of my solutions. That's why we say that they're possible, because it might not be a unique solution. It might be something that's already on there more than one time, right? So when I'm in a factored form, I set it equal to 0. It's already factored, so I'm going to set each factor equal to 0, find my solutions, and then make sure I state any of the multiplicities if they are in the equation. Now, remember, this is just one form of the equation. So in this video, we're looking at factored form. We still need to, though, look at how we would do this in standard form. How would we solve a polynomial?